So this note card is number 89. Title is Geometric Probability. So to explain this concept, we're going to put a picture on the note card of a rectangle. And this is going to be 3 inches on this side and 4 inches on the bottom. So here's the 3 inches, 1, 2, 3. Here's the 4 inches, 1, 2, 3, 4. I'm going to draw in the squares. And then I'm going to draw a rectangle inside the square, inside the other rectangle. So what's the area of the large rectangle? Yeah, 12 square inches, yeah. So how'd you get that? 3 times 4, good. So take the area of a rectangle and just multiply the sides. So then you got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 squares, right? That's why the area is 12. So then you got this other rectangle in here with an area of 2. So here's the concept for today. The question is going to say, if a point is chosen at random inside the large rectangle, if a point is chosen at random inside the large rectangle, so maybe you're throwing a dart at this rectangle, and you know for sure that you're good enough to land it inside the big rectangle. So a point is going to be chosen at random somewhere inside the large rectangle. So then the question is going to be, if you pick a point inside the large rectangle, what are the chances that the point is also inside the smaller rectangle? So you're choosing a point at random inside the large rectangle. So it could be anywhere inside the large rectangle. And what we're going to try to figure out is, what are the chances that that point that you pick also happens to be inside the smaller rectangle. So what do you think? Yeah. 2 out of 12, right? Because there's 12 squares that could be hit overall, and there's 2 squares inside the target, so the chances is 2 out of 12. So the concept today is going to be geometric probability, and what you do to figure out geometric probability is you make a fraction of course. Because probability is always a fraction, like 1 out of 6 or 3 out of 12 or something like that. And on the bottom, you're going to put the total area. And then on the top, you're going to put the target area. So you're trying, in this example, you're trying to hit the small rectangle. So the target area was 2. But the total area, the total possibilities are 12. So that's why it's 2 out of 12. All right, that's it for the note card. Title of the paper is also geometric probability. That's the title of the paper. Here's the picture for number 15. And the directions say, what are the chances? So we're going to give a probability. What are the chances that if you choose a point at random inside the rectangle, what are the chances that it's also inside the triangle? So the target is the triangle. We want our point to be inside the triangle. But we don't know for sure that it's going to be inside the triangle. It could be anywhere inside the rectangle. And we're trying to figure out what are the chances that it's going to be inside the triangle if we know it's going to be inside the rectangle. So what should I do to figure that out? Yeah. The area of the rectangle, awesome. So a rectangle is a parallelogram because this side's parallel to that side's parallel to that side. So area formula for a parallelogram is base times height. So the base is 33 and the height is 12. If I remember right, that comes out to 396. On a good day, I can remember the numbers from first period. Depends on how much sleep I got. Okay, so the area of the rectangle is 396. So no code for it. All right, so Maddie got us started. She was right. We need to find the area of the rectangle. What else do we need to do? Yeah, Charlie?
Find the area of the triangle.
Awesome. Find the area of the triangle. What's the area formula for a triangle? Yeah, Emma? Good. I like how you said it. Base times height divided by 2. That's totally fine. Or you can write 1/2 times base times height. Same thing. So for this triangle, the base is 11. And then the height, don't forget about the definition of a height. A height is supposed to make a 90-degree angle with the base. So see this dashed line here? That's making a 90 with the base. So that's why the height is 5. So 5 times 11 is 55, 10 times 1/2 is 27.5. All right, good. So we're on our way. We found the area of the triangle. We found the area of the rectangle. Now the question is saying, what are the chances that if you choose a point at random inside the rectangle, what are the chances that the point would happen to be inside the triangle? So what can we do to figure that out? Yeah. Good. So the target area is 27.5. The total possible area is 396. So you just make a fraction out of that. It's okay to leave it as a fraction. We did that on this problem. Although if it was a problem, I probably would have reduced this to 1/6. This is okay. You can also divide it out and get a decimal. So the probability is 0.0694. I just got that by taking 27.5 divided by 396. And then sometimes you can turn it into a percent. The way you turn a decimal into a percent is you move the decimal 2 places. So past the 0, past the 6. So that would be 6.94%. So just to talk about it roughly, it's about a 7% chance. Fairly unlikely, right? Which makes sense, because if you look at this rectangle, the area of the triangle is pretty small compared to the area of the rectangle. So that's why there's such a small chance that the point would be inside the triangle. Just about a 7% chance. So that, again, that means another way of saying that is if you had 100 points inside of here, about 7 of them would be inside the triangle. All right, next we're going to go to 19. '19 has a pentagon. And the directions say that the pentagon is regular. What does that mean if the pentagon is regular? All sides are equal, all angles are equal, right? So, all sides equal, all angles equal. Then they have the apothem label. So the apothem goes from the center, makes a 90 with the side, and this one is 3 centimeters. So it's a regular polygon, and the question says, one of the questions on this question is find the area of this. So how do you find the area of a pentagon? Yeah, it'll get us started anyway. Good, 1/2 PA. Now this does not work on all pentagons. It only works on regular pentagons. But this pentagon is regular, so we can use it. They gave us the apothem. It's 3. So 1/2 times perimeter times apothem. Now finding the perimeter is going to be tricky because they didn't tell us the side. Now in some of the problems they tell you what the side is and then finding the perimeter is easy. Okay, but we're going to have to go off to the side and do a fair amount of work before we can figure out this perimeter. But don't let that cloud this fact that we're just taking 1/2 times perimeter times apothem to find the area. All right, in order to find the perimeter, we're going to need to know how big these angles are. So I need to know how many degrees that angle is. So first, before I can figure that out, we're going to figure out how much all of those angles add up to. So there's a formula for how much the interior angles add up to. Yeah, you got it? Awesome. So the formula 180 times n minus 2, that'll tell us what the interior angles all add up to. Now n stands for the number of sides, so it would work for any figure. In this case, this is a pentagon, so it has 5 sides, so we'll put a 5 in for n. So 180 times 5 minus 2. 5 minus 2 is 3, so you just take 180 times 3, and 180 times 3 comes out to 540. So this is telling us that all of these angles inside the pentagon add up to 540. And actually, inside any pentagon, the angles would add up to 540. So how can I figure out what one of them is? Yeah.
Divide by how many sides are.
Yeah, just divide by 5, because there's 5 angles. Now, on a different pentagon that wasn't regular, they wouldn't all be the same. But on this one, they're all the same. So you take 540 divided by 5, and you get 108. So that means this is 108 degrees. This is 108 degrees. That's 108. That one's 108. That one's 108. They're all 108. And that means then they're adding up to 540. All right, now I need to draw another line in here. And what that did was it took the 108 and bisected it. So now we know that this angle in here is 54. That one's 54 also. So the reason I drew that extra line is now I have a right triangle. And when you have a right triangle, there's a lot of formulas that we can use on that. All right, so now I'm going to enlarge this triangle so we can look at it a little closer. So here's the 3 centimeters, here's the 90, and here's the 54. I need to find out this so that I can find out the length of the side. Because once I have the length of the side, then I'll be able to figure out the perimeter. I'm going to find this out. I'm going to call it x. That's over here. Three is across from 54, so it's opposite. And x is next to 54, so it's adjacent. What's this side called? Hypotenuse, because it's across from 90, right? We don't need it on this problem, that's why I'm not labeling it. But just as a reminder, that's called the hypotenuse. All right, so we've got opposite and adjacent. So which trig function uses those? Awesome, tangent, nice work. So you write down tangent, then you write down the angle. And then that is opposite over adjacent. You're doing good. Thanks for listening. Everybody okay with this setup? All right, now we're going to use our calculator to figure out tangent of 54. I don't think I got that right. It's been an hour.
It's 1.3763.
1.376. Okay. That wasn't terrible. 1.375. What's after the 5?
1.376.
And what's after the 6?
38192.
1.3763?
Yeah.
All right, thank you. So this is the tenths place. This is the hundredths place. This is the thousandths place. That's the 10,000ths place. So if I'm going to make this a fraction, it's out of 10,000. And then it's 13763 out of 10,000. Now this fraction looks kind of weird because the number on top is bigger. But don't let that throw you off. I mean, that just means the number's bigger than 1, right? 10,000 out of 10,000 is 1. So 13,000 out of 10,000 is bigger than 1. But that's okay, because this number is bigger than 1. So then that's 3 over x. Now we're almost home free. Now you just do cross products. That's easy. 13,763x equals 30,000. Then you divide that out. .18. That means back to this picture, that's 2.18. So that means back to this picture, that's 2.18. I'm really needing the side of the pentagon. So I'll take the 2.18 times 2. That's 4.36. It's a regular pentagon, so they're all 4.36. So to get the perimeter, I take 4.36 times 5. .8.
Yeah.
So thanks for hanging with me. That's the perimeter of the pentagon. So then you put that in over here for P. And now finally we can figure out the area by taking 1/2 times perimeter times apoph. Area of the Pentagon is 32.7 square centimeters. Okay, but now back to today's concept. On this problem, the whole entire Pentagon is shaded in. And the question says, if a point is chosen at random inside the Pentagon, what are the chances that it'll land inside the shaded part? So if you pick a point somewhere in here, what are the chances that it'll land in the shaded part? 100%, right? Because the target area is 32.7, and the total area is 32.7. So you take the target area divided by the total area. So if that had been the only question, we wouldn't have even had to figure these out, right? We could just put 100% down. But it also said find the area, so that's why I did that. Plus, yesterday that was a tough problem, so I wanted to make sure we did it again.